Good morning, everyone, and welcome to the webinar of Solar O&M Innovation and Best Practice. It's a real pleasure for us to organize such an event to share the best practices of our market. And we are very pleased and honored to have so many participants to this webinar. It has been a very successful launch. I hope that you will all enjoy this sharing session where we really have great people who participate to provide their vision on the future of solar O&M and the trends which are changing our markets, and give you an overview of which are the best practices in different places by different actors, whether they are EPCs or cleaners or people selling measurement devices. You will see a very wide range of actors. And this is really the purpose of this event, is to have a wide view of what are the trends so that we can raise the awareness of the problematics of O&M worldwide. It's the first edition. We hope there will be many others, and we wish you a very good and enjoyable webinar. I hand over to Romain.
Thank you, Christophe. Thank you for the introduction. Good morning, everyone. My name is Roman. I'm also part of SolarCleano. Today, I will guide you through the webinar, and we have a very exciting agenda with different speakers from all over the world. So let's not wait, and we're going to start first with our friend, Mr. Bruno Queiroz from the company Chemitech based in Portugal. I guess he's the best expert to talk about soling, because at the end of the day, if you want to understand correctly the O&M challenges, we need to understand what is soling and its impact. The chapter 2 will be talking about monitoring, because we need to be able to monitor the soling and to understand a bit more what means preventive maintenance. For that, we're going to have two interesting speakers, Mr. Udo Kronmüller from OTT Hydromet from Germany, who is going to talk a bit more about a very interesting monitoring tool. Then after that, we will have our friend, Mr. Michalis Papagorgiou, I hope I mentioned it correctly, from Warby, from Cyprus, talking a bit more about thermal analysis, thermography, I would say. Then we have the chance to have very great speakers coming all the way from the USA, Mr. Clifton Clark, who will focus a bit more about one specific case study. The idea of this case study within Engie USA will be to talk a bit more about the importance of safety. So I really look forward to this discussion with our friend Clifton. And then, because we want to keep you all until the end, and we want to make sure that to have all of you focusing as well on the last presentation, which will be extremely interesting. We're going to conclude with Mr. Pierre Chatney from EDF Renewables based in Dubai, we will talk a bit more about the future of solar energy, because it's interesting to understand O&M. It's interesting to understand the different challenges, the best practices. But at the end of the day, we need to know what's next. We need to understand what are the future challenges to make sure that everybody is well prepared. So once again, as mentioned by Christophe, we would like to thank you all for joining us for today's sessions. We will, after these different exchanges, these 4 chapters, conclude all together. And yeah, during these complete sessions, if you have some questions, feel free to take note of them. Feel free to note any questions you might have in the Q&A bar that you will see a bit later. And then we will make sure to answer all your questions in the Q&A sessions. Please note as well that the webinar will be recorded, so you will have the chance as well to see it again and again and again. So before concluding, I guess you've seen that we have another good partner of us part of this webinar. His name is Kim Verdugt. A lot of you, I guess, already know him. I really wanted to have Kim part of this webinar because Kim managed to create something pretty big for the O&M industry, for the cleaning industry, if I can say, which is called the SolarCleano network. I guess, Kim, the floor is yours. If you can let us know a bit more about what's going on nowadays with the SolarCleano network and what's your role in this webinar. And then I guess we will be able to start with our friend Bruno from Chemitech.
Yeah, well, for those who don't know me yet, my name is Kim Verduigt. I'm from Belgium. I founded the Solar Cleaners Network 2 years ago already. And it's an honor to be here today and to be invited by amongst all the mammoths in the industry like SolarCleano. Within the Solar Cleaners Network, our goal is to educate both the solar cleaning professionals, but also the entire O&M industry about best practices, how to remove specific types of soiling, and that can go all the way up to safety, of course. We carry a big responsibility. Our job is not to be taken lightly, so it's a pleasure to be here and to be invited by you, of course. In addition to discussing soiling and monitoring solutions, we'll also walk you through a case study which will showcase a real-world example of how effective O&M strategies can make a significant impact on the performance and the longevity of solar panels. This is where theory meets practice, of course, and you'll get to see the results of innovative O&M in action. Finally, we'll close by discussing the future of energy, focusing on where the solar industry is headed to, and how O&M practices will need to evolve to keep up with the increasing scale and complexity of solar installations. We'll be looking into trends like AI-driven maintenance, but also automation and sustainability initiatives that are shaping the entire future of energy management. So I'll give the word back to Christophe.
Thank you, Kim. Thanks for your participation, and I really want also to share this thanks to all the person who will present in the following session. As Romain mentioned, there is a question box that you can where you can raise your questions. They will be answered in, after the session. And enjoy the webinar, and looking forward to your feedback about it as well.
Thank you. All right, so let's move to our first guest, Mr. Bruno Queiroz from Chemitech, based in Portugal. Bruno, how are you doing?
I'm fine, thank you. Glad to be here.
So today, as you know, we're going to discuss a lot about O&M, about really the importance of maintenance, the importance of understanding what is sometimes cleaning. And I really believe that when it's about understanding what is soiling as well, you have, I would say, the best position to explain us a bit more. So during this short chapter, 8 minutes, so Bruno, I invite you to talk a bit more about what is soiling, what is its impact on the solar panel efficiency, and the floor is yours.
Okay, thank you. Indeed, soiling is a problem that it's forgotten a lot during the development stage, during the engineering stage. And from what we hear, it's basically just an Excel cell that is considered like a 2% value assumed per year. In some cases, it can be true. In others, it's not the reality of the business. On average, and this is a study from 2022, the industry as a whole is losing 3 to 5 billion euros to soiling on a yearly basis, and it's only getting worse because as the industry turns to solar, that's when most of the problems start to appear. Industrial rooftops are quite prone to have problems. And as utility sites also, the best ones are being used, you'll start to use sites that are not so perfect for solar. So the soiling issue will only grow throughout the years. We can see from the most common type of soilings like bird droppings that you can find almost in any site, especially if it's by the coast. You'll have seagulls mainly that can cause huge problems, like the picture that we are seeing. Have Northern Europe with lichen, also a very common problem and can be very damaging to modules. If you go to the tropics, you can find fungi due to the humidity and the heat that is always present. Desert regions, dust, sand, also quite common. Even nowadays, the Sahara Desert can have influence not just in Europe, but all the way to America also. And for example, in industrial sites, the cement dust is a quite common problem. And we have seen sites losing well over 70%. I have some examples here. A site in Northern Europe with cement dust was losing over 70% losses. Bird droppings in the UK over 15%, and fungi in the tropics in the Caribbean over 20%. And actually, from the three problems here, the most damaging to the modules, it's probably the bird droppings, because they are the ones that can cause problems directly to the modules themselves. Although we are not losing as much production as the other ones, it's the one that can be damaging to you more to the module, and I'll explain in a little bit. So we assume that cleaning is a given. Cleaning is a need that is already established, and that the asset owners know that they need to clean. The only issue is that there isn't one size fits all cleaning schedule. Each plant should be assessed individually. There are plants that can stay over 2 years without needing to be cleaned. Others, we have seen plants that are cleaned every 2 weeks because they are located next to an industry on a very dusty region, and they have an incredibly high soiling rate. Even though, now, as I told before, the rule of thumb for ground installations is 2%, because it is the point where usually on the utility scale, it's where cleaning becomes financially sense. It makes sense to clean because you will pay for the cleaning with the gains that you'll get. Of course, the cleaning schedule needs to have in account the type of soiling that you have, the soiling rate, how much you are losing every month, the guidelines of the manufacturers, also important to follow, and whether you are using soiling mitigation coatings or not. Soiling mitigation coatings can help you to extend the cleaning, the time between cleanings, but can also be used as prevention to make cleaning easier and not change the cleaning period, so to speak. So what happens if the plants are not cleaned? The most common problems that we'll find are hotspots. It's basically any type of shadowing on the module. Concentrated shadowing will create increases in temperature due to the lack of sun. It's especially important on soil banding, the soil that stays on the bottom of the frame of the modules, because rain will drag all the dirt to the bottom of the module, and it will stay there, block sunlight, and create hot spots as we can see in the picture. The other ones is bird droppings. It might not seem that much important, but once again, it's a concentrated soiling, and that creates huge problems by creating hotspots that can lead to damages to the modules and even to ruining completely the module and having to replace the module itself. Besides hotspots, the presence of soiling can damage seal coatings, the seal silicone next to the frame that can lead to water ingress, soiling such as cement and bird droppings, because they are either acidic or very alkaline. They can wear off the anti-reflective coating, also very important to have in mind during the cleanings. So all this combined, it will result in substantial financial losses, reduce the lifespan of the module, and which in the end will result in much lower ROI than expected, and increased O&M costs, downtimes. So it can be messy not to clean or to neglect the PV plants. They are low on maintenance, but they are not maintenance free. So talking about the manufacturers, there are common guidelines to most of them, such as cleaning with soft water, with low mineral content. Any type of cleaning agent or detergent should be environmentally friendly and approved in advance by the manufacturer. Cleaning should take place during the cool hours and when also they are producing less to reduce electrocution risks and thermal shocks. But of course, we know that in several installations this is not possible. This is a nice to have, but on a utility scale, it's impossible to schedule because we'll be cleaning for days. So that is a risk that needs to be mitigated by heating water or using some type of insulation from electricity to protect the operators. Finally, any type of use of scrapers or high pressure machines is also prohibited because it can damage the surface. High pressure machines can blow off the seals on the modules that will lead to water ingress. So it's something that we need to have in account also when deciding how to clean. This is where we enter, is when water is not enough, where just cleaning with soft water will not be able to solve your problem. That's when we work with the customers by supplying specialized cleaning agents, commonly called chemical cleaning. And it's basically custom-made products designed for solar, certified for solar, that are made to clean specific contaminants. Can be cement dust, can be rust or metal oxides, can be paint, even lichen. So it's something that we work on a daily basis to allow asset owners not to have to change modules in several times or relocate the plants also. It has happened that where the soiling rate was so high, the contamination was so high, that just the sensible option was to move the PV plant to another space. Otherwise, the costs of keeping the plant clean will be extremely high. The use of coatings also allow the possibility of cleaning with water instead of using always a cleaning agent. So that's something that we develop also, and we always recommend when using one of our products, first clean with a specialized cleaning agent and then protect with the soiling mitigation coating. So the next cleaning is easier and you don't need to be always using the more expensive products to keep your plant clean. This is especially important for cases as cement dust, rust, metal oxides, where water alone and scrubbing is not enough. Just give you an idea on the numbers. Of course, this will vary according to the region where you are located, by the irradiance, by several factors, by how much you are selling or buying energy. But a rough idea is a contaminated plant of 10 megawatts that is losing 40%. We are talking about losses of 600,000 euros per year. The cost of cleaning should be around 120,000 euros, which it implies an ROI of 2.5 months, which is more than enough to justify the cleaning, not accounting also for the keeping your modules working properly and having the lifespan that is expected. On a utility scale plant, for example, that is mostly dust, organic soiling, and the use of a soil mitigation coating, even if it provides just 3%, we are talking about 450,000 euros on a 100 megawatt plant. And the cost of using the coating is around 50,000 euros, which means that you'll have netted 400,000 euros of production and an ROI of well, a little over half a month. So 20 days or so should be enough to pay for the cost of applying the coating. So this is some of the numbers that not most people know or have an idea of how much soiling can cost you. And it's something that we talk about on a daily basis because cleaning is not a cost, is an investment, so to speak. So just to finalize, Chemitech, as we explained, we are based in Portugal. We are focused on the solar industry, and we develop the products that are certified for solar by listening to the industry, by seeing what are the problems that we can help solve, and that's why we have created our range. And that's the way we are keeping in the future, is listening to the cleaners, listening to the O&M companies, and making their life easier by making them more efficient.
All right. Thank you so much, Bruno. We did a bit more than 8 minutes, but it's totally fine because what you've been sharing was extremely interesting. I guess now we have a good overview of why we need to clean solar panels. But what I was pretty interested to see here was was to see the mention about the return on investment. Mm-hmm. So thank you for your time, Bruno. I see you in a bit. Sure. Now that we know what is soiling, that we know why we need to clean solar panels, we're going to move to the next chapter where we're going to talk about measurement, how to monitor all of this, and let's talk a bit more about preventive maintenance. Thank you, Bruno, and I'll see you soon.
See you soon.
Let's welcome our next two guests, Michaelis from WarpBips and our friend Uto from OTT Hydromet. So briefly, recently, we just discussed with Bruno about soiling, about really the impact of soiling and why we need to clean. Now, let's talk a bit more about the role of correct monitoring in Solar O&M. And for this, I would like first to introduce you and to invite Udo to talk a bit more. So Udo, can you take the lead right now and share your screen so that we can discuss a bit more? And I guess, Udo, while you're preparing your screen, what will be the question one that I would have for you is, could you explain a bit more the importance of measuring soiling levels on solar panels and how your equipment can help in this regard? The floor is yours.
Yeah, thank you so much, Romain. And just a quick feedback if my slide is now visible for you.
All good.
Okay, then thank you so far. And yeah, honestly speaking, I guess a soiling measurement is more or less a no-brainer, at least in these red areas on the globe that you can recognize on this soiling heat map in the left part of the slide. So together with solar irradiance and module temperature, soiling is one of the most impacting environmental parameters to evaluate the performance ratio of a PV plant. And therefore, of course, it should be measured properly. Soiling layers and all the other dirt particles on the glass surface scatter simply solar irradiance away from the solar cells underneath. And this will directly lead to a performance loss of the module and the complete plant. And to measure this soiling loss, our Keep and Zone and Dust IQ sensor can easily be attached into a string or into an array and measures 24/7 the actual soiling ratio based on an optical measurement principle. That means it doesn't require any self-cleaning or maintenance on site like most of the other soiling sensors on the market do. And to give you an example, you can see some applications on the right side of the slide.
Perfect. Thanks, Udo. Thanks so much. And if I may ask you, I mean, how does accurate monitoring, soiling a measurement, contributes to a complete overall O&M efficiency?
Yeah, sure. Well, there are two major benefits that the DustIQ soiling sensor provides to the operators and to the O&M people. The first is the determination of the actual soiling losses as part of the overall plant performance. And the second is the forecasting of this break-even point. That means when is the best time for the panel cleaning, considering the cleaning costs against the higher yield afterwards.
All right, excellent. Well, thanks, Udo. We'll come back to you in a bit. Just before we discuss a bit further, let me just introduce you to Michalis. And Michalis, I would like to invite you to share your screen as well, as I guess you prepare something for us. And Michalis, while you prepare everything, I guess I will start with a question which is quite important for us, as you are quite an expert when it's about drone inspection and so on. And well, what is the role of drone thermography in monitoring solar panels and in, I would say, identifying issues related to O&M and soiling and so on?
Sure. Thank you for the invitation, Roman. On my slide, let's see a breakdown of the role that thermography plays. So drone thermography is actually transforming how solar panels are monitored and maintained using thermal imaging to quickly detect issues that might otherwise go unnoticed with the naked eye. Drones can effectively inspect large-scale solar farms covering 1,000 panels in a fraction of time that it would take if you do it manually. And of course, you can easily reach difficult areas in different sites around the world. The thermal cameras, they do detect various issues related to electrical faults, and these faults reduce efficiency. Drones also identify soiling, as Udo mentioned, that effectively blocks sunlight, which impacts the energy output. So beyond fault detection that we mentioned just now, drone thermography also helps optimize preventive maintenance. By monitoring the thermal patterns over time, we can predict potential failures, enabling early and targeted repairs that can extend the lifespan of PV panels, and of course, reduce any potential costs for the owners and the solar operators. The data are collected in integrated with advanced analytics, and this helps the operators to make decisions, plan decisions that help cleaning strategies and track also other impact of other environmental factors on the site. The drones also enhance the safety on site, reducing the need of personnel to work in hazardous areas or conditions, allowing inspections to be held on from a safe distance. Drones also provide high resolution and documentation for regulatory compliance, insurance purposes, or performance warranties, ensuring that there is a stakeholder transparency in the process by creating detailed reports that build trust. And if we see the slide as an overall, drone thermography, it's a critical tool for us as it improves efficiency, safety, and cost effectiveness for solar asset management. And as technology advances, I'm sure that the role of this technology in the renewable energy sector will continue to grow more and more.
Yeah, agreed, definitely. I mean, thanks a lot, Michalis. Might you have some example or case studies where globally you can see, I think you prepared this something for us where you can see the importance of thermography in this O&M strategy?
Well, allow me to share some insights, as you can see from the slide, from our inspections here in the island of Cyprus, where we are inspecting annually more than 50 megawatts in more than 30 sites. The last 2 years, we inspected more than 190,000 modules. That sums up to around 8,000 strings. And we have detected more than 1,750 issues that averages around 35 issues per megawatt. These issues have affected around 2% of these 190,000 modules. And if we give an estimate of the affected average power, we'll see that out of those 50 megawatts, we have 1.15 megawatts that are, let's say, severely underperforming. And as going one step further, we have the top 4 issues that we anticipate in every inspection, which is multi-hotspots, open strings, malfunctioning trackers, seeing the other way than they're supposed to do, and burnt diodes. These are the top 4 findings, let's say, that we have here in Cyprus. And these insights actually illustrate how drone tomography significantly helped the respective maintenance teams by providing, let's say, detailed real-time data that allow them to be more efficient on site, targeted and using targeted and cost-effective maintenance, let's say, practices. And this ability to quickly identify and address issues such as electrical faults or even soiling, meaning cleaning needed, leads to increased energy production and reduced downtime of the asset, which provides a substantial return on investment for the solar operators, but also for the solar asset owners.
Perfect. I mean, that's where we also see the importance of preventive maintenance, the importance of this. At the end of the day, the only goal is to increase this energy production. Thanks so much, Michalis. I guess you can stop sharing your screen and we can have a quick last questions, the 3 of us. Maybe Udo, Michalis, I will move really to these last questions to conclude. What future trends do you, foresee in the field of solar monitoring system? How can companies prepare for these trends coming? I don't know how you see the things. Udo, maybe if you want to start.
Yes, of course. We are seeing a growing demand for complete environmental monitoring solutions for PV plants across the globe. And complete, in our sense, means that it's not just about soiling, but it's also about all the other environmental parameters that impact performance ratio, like irradiance, most of all, of course, but also like temperature, like wind, precipitation, humidity, and so on. And of course, it's about all the reliable data processing afterwards that is linked to it. So think about data loggers and data transmission. And we as Ort Hydromet, with our 2 brands, Kip and Sonnen and Luft, we are in the great position to meet all these demands from just one single source then.
Perfect. Thanks so much, Udo. Michalis, some comments on your side?
I think it's a very, very interesting question because we see the speed of technological advancements surprise us every day. So we see things sooner than expected in terms of applicability. I mean, even here at work, we are already working with wearable devices, for example, of mixed reality for the field technicians to provide them with real-time data, overlays, instructional guides, visual diagnostics, being on site. Nevertheless, I mean, to answer the question, I would expect that the future of solar monitoring will be more driven by AI, machine learning, for sure.
Fully agree, yeah.
Even more automated operation maintenance and remote troubleshooting. We'll have, for sure, advanced inspection robots on site, digital twins based on the drones technology that is in the cameras. Computing is going faster and faster. Cloud-based monitoring platforms to integrate all the assets together. Even blockchain for energy management, for example, alongside the integration of battery storage and smart grids. So to this sense, how the companies should prepare. I mean, companies should actually prepare to invest, if not already invested, to these innovations. Therefore, building, let's say, internal expertise in data science, automation, while they develop partnerships with other tech providers. So by staying ahead of these trends and embracing this sustainability and scalability of these solutions, they can enhance their operational efficiency, they can reduce cost, obviously, and at the very end, ensure their leadership in the renewable energy sector and their marketplace.
Yeah, I mean, and there is a key thing, I guess you mentioned this AI topic is, I would say, massive when you look what's coming, and I see as well in the short future that globally all these technologies, it can be for thermography, for cleaning, for building solar panels, for recycling solar panels. At the end of the day, everything is kind of linked to get a global O&M strategy, and that's what we're trying to understand within this webinar. And I really look forward as well to another chapter where we're going to talk a bit more about the trends just of the renewable industry, of the solar industry. Well, thank you, Udo, Michaelis, so much for your time, for your expertise. Really appreciate that. I guess it's interesting for everybody to understand a bit more about this monitoring system, this thermography aspect that I still believe a lot of company underestimate. So thanks to both of you. Right now, we're going to move to the next chapter with our friend Clifton from Engie USA. We will share a bit more details about the specific case study. Michaelis, Udo, I see you later. Thanks so much.
Thank you, Roman, for having us on board. Thank you.
Thank you.
So now let's welcome our new guest, Mr. Clark from Engie North America. Mr. Clark, it's a great pleasure to have you with us today. How have you been so far?
I'm very good. Thank you, Romain. And thank you for including me in your webinar.
Thanks a lot. So, Clark, today, I guess you're going to talk more about safety within this complete O&M strategy, because today we've been talking about a lot of topics within the O&M industry, but one key thing is safety. And interesting fact as well is that you're going to talk more about a specific case study, talking a bit more about cleaning and robotics. So, Clifton, thank you once again. And the floor is yours. So I'd like to invite you to share your screen.
Okay.
Here you go. And you can go back to the first one, tip top. It's all good.
Okay. Does everything look okay on your end?
Yeah, all good.
Okay. Well, hello, everybody. Once again, my name is Clifton Clark, and I am an O&M customer care advisor for Engie North America. Today, I will briefly discuss the importance of O&M and safety, with a special focus on my efforts at addressing the labor intensity of washing solar panels. But first, a quick background of the company that I am very privileged to work for. Engie North America is a subsidiary of the global energy and services group Engie, and operates across a broad spectrum of energy-related activities in North America. Its operations include energy generation, energy management and services, renewable energy projects, energy infrastructure, and environmental sustainability initiatives. Overall, Engie North America's operations are centered around providing sustainable energy solutions and contributing to the transition towards a cleaner energy future. And now on to the main topic. The importance of O&M and safety. In the solar energy industry, I believe implementing robust operations and maintenance practices alongside stringent safety measures is essential for balancing risks and rewards. Effective O&M practices enhance operational efficiency, reduces costs, and extends the lifespan of solar equipment. This approach not only optimizes performance, but also mitigates the risks of unexpected failures and costly downtime. On the other hand, comprehensive safety protocols are critical for protecting our workers, preventing environmental incidents, and ensuring compliance with regulatory standards. While these measures can be resource intensive, the benefits include a more reliable, efficient, and sustainable solar energy sector with reduced risk of accidents, environmental harm, and regulatory penalties. The specific initiative I've chosen to discuss today in regard to O&M and safety is the labor intensity of solar panel washing. Labor intensity in washing solar panels presents significant challenges in the operation and maintenance of solar systems, with serious safety concerns, particularly related to worker fatigue and the physical demands of the job. Cleaning large numbers of solar arrays requires repetitive, physically demanding work, often over extended periods, leading to significant fatigue. This fatigue can diminish the concentration and increases the likelihood of mistakes. Workers are frequently exposed to extreme weather conditions, such as intense heat, rough terrain, and direct sunlight, which exacerbates fatigue and can lead to heat exhaustion or other health issues. Fatigue not only reduces productivity, but also heightens the risk of accidents and injuries. As it sets in, workers may experience impaired judgment, slower reaction times, and decreased coordination, all of which increase the risk of accidents, especially when working with heavy equipment, working at heights, or in other challenging environments. Providing comprehensive safety training that includes a focus on risks associated with fatigue and labor intensity has and always will be an integral part of protecting our workers. However, several years ago, I decided to take things a step further by seeking out and implementing the use of robotic cleaners. And while there still is substantial room for improvement, the outcomes and benefits have already been very significant. Without question, the immediate benefit noticed was the reduction in physical strain on our teams. Solar panel cleaning often requires workers to perform repetitive, physically strenuous tasks, as I've mentioned previously, which can lead to physical exhaustion, muscle strain, injury, and other long-term health issues. By handing those tasks over to robotic cleaners, the physical demands on human workers have been greatly reduced, alleviating physical strain and contributing to their overall well-being. Another great benefit, of course, is improved safety, as our teams can now work from a single, more comfortable vantage point, as depicted on the right side of my slide here. This benefit reduces, or in many cases, eliminates the need to navigate elevated or hazardous areas, minimizing risks such as falls and electrocution. Now, with robotic equipment taking over these tasks, our workers can monitor the cleaning process from a secure location, completely avoiding these dangers. Additionally, the robots also bring a level of consistency and precision that is hard to match with human workers alone. People get tired and can miss spots, but the robots maintain a steady performance, ensuring that our customers' solar arrays are always cleaned thoroughly and efficiently, which improves the overall production of their solar systems. Furthermore, being able to see and experience this benefit, in addition to less risk and strain, our workers are more satisfied in their roles, resulting in a much improved team morale. I don't think anyone can argue with the fact that happy workers and happy customers creates a mutually beneficial relationship, where satisfied employees deliver better service, which in turn leads to more satisfied customers. This positive dynamic fosters loyalty, productivity, and a thriving business environment where everyone feels valued and invested in success. So in conclusion, O&M and safety are critical for Engie's success and sustainability, as they ensure operational efficiency, minimize downtime, protect workers, and comply with regulations, ultimately supporting reliable and sustainable energy solutions. I encourage everyone to prioritize O&M and safety in your own roles and projects. By focusing on robust maintenance practices, rigorous safety protocols, and industry-leading technology, you not only enhance operational efficiency and reduce risks, but also contribute to the long-term success and sustainability of your projects. Thank you all for your time and attention, and thank you for your commitment to prioritizing O&M and safety.
All right, Clifton, thank you so much for sharing this very interesting topic, the case study as well. And once again, thank you for, I would say, all the good feedback you've been sharing to the, I would say, SolarCleano team for the past few years. I look forward to the questions that we're going to have from it. And then I'll see you again in the Q&A session. Thank you, Clifton, and enjoy then the rest of your day.
Thank you, Romain, and thank you for including me again in your webinar. It's a pleasure to work with you and your team, and I look forward to all the great things that we will continue to accomplish together.
Excellent. Thank you. So next, move now to our next speaker, Mr. Pierre Chatney from EDF Renewables based in Dubai. I'm really glad to have Pierre with us today, who is going to talk a bit more about the solar trends of all over the world, but as well mainly for EDF. What will be interesting, I guess, with this short presentation is to understand a bit the technology evolutions. We will talk, I guess, a bit more about CapEx as well, the CapEx evolutions for the large-scale project. Something that I really like as well, the importance of AI coming as well for all this project, recycling topics, and so on and so on. So, Pierre Chatney, thank you for joining. Hope you're doing well.
Thank you. Thank you. Doing very well.
So Pierre, so that way we don't lose too much time, I would like to give you the opportunity to share your screen right now and to share what you have to share with us.
All right. Thanks. Thanks very much, Romain. So yeah, today I'm going to talk to you about the future of solar PV, solar energy. A little bit first of all about myself. So I'm an asset operations manager based in Dubai. I have around 10 years experience in renewable energies, and my role is to follow solar plants operations in the Middle East, boosting performance of the asset, focused on the improvement and innovations with, at the moment, development of a solar test field to challenge existing models and test new solution to stay ahead of the curve. So that's my role in a nutshell here. And a little bit about EDF Renewables for the one who don't know. So it's an international energy company which develops, builds, and operate power generations plants. At the moment, we have around 21 gigawatt gross installed wind and solar capacity worldwide, which include 4 gigawatt in the MENA region, and 4 gigawatt are in construction at the moment. So we'll jump to 8 in the next years, with many more to come. So we are present in 20 countries, 5,000 employees, work daily to develop a low carbon energy solution, contributing to the diversification of energy mixes. So EDF is at the forefront of innovation with the implementation of new technologies and the desire to always push to the conventional limit. And we will see that in the following slides. So I wanted to talk a little bit about the history and future and where the PV come from in terms of installation of the plant. So in 2016, we had roughly 75 gigawatts of solar plant installed. And as you can see in this graph, is a rapid acceleration of the development of projects worldwide. And today, in 2024, we are about a bit less than 600 gigawatts. So compared to the initial 75 in 2016, that's a huge gap, which is driven by different things, including innovation, technology change in the main equipment, and also a reduction of the price of the main equipment that we will see later. So I mean, the plants back in 2016 when I started, when you had the 10 megawatt plants, it was really it was 10 megawatts was already a big PV plant in the region. Now what we see is plants really growing to 2.1 gigawatt, like the plant we have in Al Dhafra in Abu Dhabi, 2.1 gigawatt, which represent a plant with a bit less than 4 million solar panels, which are using trackers and automated cleaning robotic systems with different types of modules, P types and N type. Here you can see the PV modules evolution since 2016. What you need to know here, I mean, you won't know maybe all the different types of technologies of PV modules, but you can see the rapid evolutions and technology shift year on year on all these different technologies. So you see it's evolving very rapidly, changing technologies, always improving cleaning, improving efficiency of the modules, increasing a little bit the size of the cells and the modules as well, in order to always be more and more efficient and yes, to be more and more efficient and cost efficient. Okay, to be more and more cost efficient and competitive in terms of cost. I wanted to take the example of a DWAS3 project. It's a project we have here in Dubai, split in 3 phases. So they were commissioned in 2018, 2019, and 2020 in 3 different phases of 200, 300, and 300 megawatts. And for each of these phases, the technology evolved so rapidly, as I showed you before. We changed the technologies and the different types of modules from year on year. So we started with polycrystalline double glass modules. Then we moved to half-cut technology. And finally, in 2019 or 2020, for the last project, we used bifacial modules, where we were the first in the region to use bifacial modules in our plant on utility scales, which was really a challenge, but a great opportunity. And nowadays we see that bifacial is a standard. Everyone use bifacial modules, and it's beneficial here with a good albedo that we have in the region. We see here also the PV module efficiency increase of these modules year on year. Next, I wanted to talk to you about the utility scale PV project drop. So the CapEx of the project for utility scales from 2010 to 2024 and a forecast for 2025, where you see a drastic drop in terms of price linked to the module price had a big impact, and now is reduced to around 10 cents per watt, as you can see in this graph. So a rapid decrease in terms of capex of the project, which help also for the development along with the innovations of the PV module for the development of solar PV worldwide. Now I wanted to conclude with the future of solar energy. We saw the past and the rapid evolution with the technology changes. I'd like to mention the wider monitoring with digitalization and use of AI tools. It's starting now, it's currently ongoing, but I see that it will be more and more in the coming years in order to optimize several things. Such as, first of all, the generation, a big one. Then the predictive maintenance in order to optimize the OPEX cost and the number of technicians working in the plant, as well as the forecasting of the generation, which will be very important in the following years with the introduction of batteries, which is the second point. So wider integration of large-scale batteries to support the grid, integrating more and more renewable energy sources. With the price of the increasing drastically at the moment, and will come into play even more and more in the region and worldwide, which is already the case in some countries, like Australia, for example. So large-scale renewables required for green hydrogen production as well. That's a big one for the future of solar. Another point I wanted to mention is the cleaning robotics solutions. So to have more mature, reliable, and efficient cleaning solution. If I take the example of the region here, the automatic cleaning robotic system on tracking system on utility scale the operation is less than 1 or 2 years. So we have a lot of challenges, a lot of improvement to be done, since it's not. I mean, it's just the beginning of cleaning robot, and they're going to become more and more reliable, and that's what we see in the coming years with longer distance can be done by this cleaning robot, more megawatt peak that can be cleaned with one robot, adjustment of the design of the plant to also reduce and optimize the cleaning robotic solutions number and efficiencies. I take the example of the region again, like we have 0.5% soiling rate, meaning that you could lose up to 0.5% per day, meaning if you don't clean for 10 days, you lose 5% almost of your generation. So the importance of cleaning is massive in the region, and a daily cleaning of your modules is very important, and you need efficient and reliable solution for that, which is coming, and we see a lot of improvement and progress in this field. And finally, the last point I wanted to mention is more resilient design, taking into account climate change to limit the risk for natural disaster like flooding, wind event to impact the plant. So it means that you need to improve the specification of your structure and your modules, as well as the standards in order to make sure that your plant will be reliable for the coming years, including this climate change. And one point I wanted to mention also is the recycling of the PV modules, which will be coming more and more, expecting a very high recycling requirement, expecting in 2045 and 2050, where the number of modules to be recycled would be around 70 to 80 million solar panels worldwide, which is a huge amount that needs to be taken care of. And the solutions and technology that will be coming in the next few years would be very important to tackle this recycling challenge. And finally, I want to conclude and say that the future of solar energy is bright, and EDF Renewable is largely contributing to the rapid energy transition, its constant innovative solutions and projects. So thank you for listening. I hope you enjoyed the presentation, and I'm happy to answer any questions you have. Thank you.
Thank you so much, Pierre. Thank you for this extremely interesting presentation. I guess you cover a lot of topics that are crucial for everybody when we talk about the trends. It's not only about saying that everybody is going renewable, but it's also about taking into consideration the different innovation, the different technologies, the importance of taking into consideration topics such as recycling. So, Pierre, thank you once again. I guess I'll see you at the Q&A sessions, and I see you, and I wish you a wonderful day then in Dubai.
Thank you. Appreciate it.